Hello everybody, and welcome back to MrMiers Math Channel. In our rational functions chapter, we're going to talk about section 9.4, which is dividing rational expressions. It's basically the same thing that we did last section, just with one little addition, which is a division symbol. All right, it just adds one extra step. All right, so let's get into it. All right, so let a, b, c, and d be a non-zero variable expression, and we're just going to use these steps to find the quotient. If we have a over b divided by c over d, we just got to remember, how do we divide by a fraction? And how we do that is just by multiplying by the reciprocal. All right, the reciprocal of that second fraction is d over c, and then we can simply multiply across. All right, so our step one is just going to be rewrite it, and then basically same thing as we did in the previous section. Multiply the numerator and denominator, or cancel out a common factor, and then simplify. All right, so let's get into the very first example, and we're going to skip some examples, like I said last lesson, also. So we're going to skip B in the first example. In example 1 part A, first thing that we're going to do is we're going to rewrite this as multiplication. Instead of dividing by a fraction, we're going to multiply by the reciprocal. So we're multiplying by 25 on x squared. And now it's the same thing as the last lesson. All right, we're going to simplify first. That would be the quicker method. So notice we have an x in the numerator, x squared in the denominator. All right, that's going to eliminate this x and leave us just with one x in the denominator. And then 25 and 10 have greatest common factors of 5. So we're going to cancel out that greatest common factor of 5, and that leaves us with 2 in the denominator, 5 in the numerator. So what we have left over is 5 on 2x, and that's it. So pretty simple. Just that addition of one extra step. All right, we're skipping B and going on to C. We're going to rewrite this as multiplying by the reciprocal. All right, so the reciprocal of that second fraction is x squared on 8. And now, once again, we're just going to simplify. So if we simplify, we're going to cancel out one of the x's in the numerator and denominator. All right, and then our greatest common factor between 4 and 8 would be 4. And that leaves a 2 in the denominator. So we just have x on 2. And that's it. All right. So it's all about rewriting and then simplifying, and simplifying until you have no common factors. All right, so of course we're going to step up the difficulty level, just adding some more complicated factors as we go. So first I'm going to rewrite this. All right, rewrite the first fraction exactly the same as is, and you might notice we already have some common factors there that we could cancel out. And we're going to multiply by the reciprocal. So that's 5 on 5 times the quantity p minus 1, and once again, we got some common factors right there. And now that just leaves us with 5 in the numerator and p minus 1 in the denominator. If we take a look at part B, let's do the same thing. So I'm going to rewrite it first. So multiplying by the reciprocal, so that would be 5 on 5 times the quantity r minus 7. Now let's cancel out some common factors. So r minus 7 and r minus 7, 5 and 5. And now r minus 4 on 9r would be its simplified form. Remember, we can't cancel out those r's. To get rid of an r minus 4 in the numerator, it would take an r minus 4 in the denominator. All right, we're really speeding along here. We are going to skip part D once we get there. So let's take a look at example 3, parts A and B first. All right, so in these, we're going to have to do some factoring, of course. So first step would be to rewrite it. So we're going to rewrite this as its reciprocal, 2x plus 10 on x. Now let's simplify what we can. So we're going to factor 3x plus 15. That's going to be 3 times the quantity x plus 5. And we're also going to factor 2x plus 10. We factor out a 2, we get 2 times x plus 5. We can cancel out the x plus 5s, and then we could write the simplified form, which would be 2 on 3x. All right, one thing that we could have done to avoid maybe some unnecessary steps is, as we rewrite it, we could also factor at the same time. All right, so that's just a possibility for future examples that we can do. So in part B, we could rewrite it. Now this looks rather odd. Usually we have the variable expression first. So we're going to rewrite that variable expression first in part B. Now dividing by x minus 2. Remember, there's always an implied denominator of 1. So when we rewrite this as multiplication, that's just 1 on x minus 2. Now we can simplify. So we could factor out a negative 3 from the numerator of the left fraction, and we'd get x minus 2 left over. So the factors of x minus 2 cancel out, and what we have left is negative 3 on 5x squared. Awesome. 2 more parts. We're just going to do C and E, and that will be it. All right. So for C, let's rewrite, and this time as I rewrite, I'm going to factor to cut out some unnecessary steps. So x squared plus 11x plus 24 factors to be x plus 8 times x plus 3. Now as I rewrite this, I'm going to factor it as well. So this is x squared plus 11x plus 24, which is also x plus 8 times x plus 3. You might have noticed these two trinomials were the same. And then we have x squared minus 81, which is just x plus 9 times x minus 9. And then cancel out what we can. Those two trinomials were the same, so they're going to cancel out completely. And we're just going to have x plus 3 on x plus 9 times x minus 9. All right, the benefit of doing something like this, writing this in factored form, would be if we were actually solving some kind of equation like this, it'd be really easy to solve. All right, last part is going to be E. All right, so one thing that I see right away when I'm just looking at this problem is right here. This quantity is not written in standard form. All right, so we could rewrite that as negative n plus 3, and that's going to help us out. So first, let's rewrite this. 1 on 8n times n, the quantity n plus 8, times, now, 5n squared times negative n plus 3 on n minus 3. Right now, it's not really apparent what all cancels out. Okay, obviously we're going to cancel out an n from the numerator and denominator, but anything more than that, this funky little factor is factorable. All right, we could factor in negative 1. All right, with that leading term being negative. If we factor out a negative 1, we're actually going to see what the other common factor is. All right, so if I factor out the negative 1 and just put it right there in front of the 5n squared, we would have n minus 3 left over. And boom, there is our common factor. And then, of course, we had a common factor of n. So when we rewrite this, we have negative 5n on 8 times the quantity n plus 8. Awesome sauce, folks. That's it. If you enjoyed it, if you found this helpful, like, subscribe, and share.